Example 5, we want to find the critical numbers of f of x, which is equal to x to the 3/5 times 4 minus x. Okay, so let's go ahead and write out that function again. So we have f of x, which is equal to x to the power of 3/5 times 4 minus x. Okay, so we can use the product rule here if we want to find the derivative of this function. So by using the product rule, we can take the derivative of x to the 3/5, which becomes 3/5 x to the power of 3/5 minus 5/5, which becomes negative 2/5, times 4 minus x. And then it's going to be plus, we know we have x to the 3/5, and we want to take the derivative of 4 minus x, which becomes negative 1. So again, just so that we know, we use the product rule to find the derivative of this function. Okay, so now what we're going to do is we're going to set this equal to 0. So we have 3/5 x to the negative 2/5. And we're going to distribute that. So when we distribute that, we distribute it to the 4, so this is times 4, minus, we have 3/5 x to the negative 2/5 times x, and then that's minus x to the 3/5. And we're going to set that equal to 0. Okay, so now let's go ahead and simplify as much as we possibly can right now. All right, so we know that we have 3/5, or in this case here, if we multiply 4 times 3, we have 12/5 x to the negative 2/5. Okay, and this becomes minus 3/5. And so this becomes 1, which is 5 over 5. So when we multiply by the same base, we have to add our exponents. So negative 2/5 plus 5/5 is 3/5. And that's minus x to the 3/5. And that's equal to 0. Okay. And so now we need to add these two fractions here. So we have 12/5 x to the negative 2/5. And so since this is 1, this becomes 5 over 5. And so therefore, when we combine those fractions, we get negative 8 over 5 x to the 3/5, which is equal to 0. Okay, so now what we can do is we can factor out an x to the 3/5. Okay, so because we know that if we take negative 2/5, okay, and if we added, or if we took negative 3/5 and then subtract that, then we would get 5 over 5, which is equal to 1. So, therefore, if we factor this out, we can factor out a 4/5 and an x to the negative 2/5. And so what's left is 3 minus 2x, which is equal to 0. So now we're going to set these equal to 0. So we have 4/5 x to the negative 2/5, and that's equal to 0. And so, or we have 3 minus 2x, which is equal to 0. So if we multiply both sides by, or divide both sides by 4/5, then we have x to the negative 2/5, which is equal to 0. Okay, and then if we raise both sides to negative 5 over 2, and raise this to negative 5 over 2, we're still going to get x is equal to 0. So therefore, for this particular value of x, we can say that it does not exist. Okay, now over here, if we solve for x, we get x, which is equal to positive 3 over 2, which tells us that f prime of x is equal to 0, and therefore it does exist. Okay, now let's graph this function on Desmos just to verify our result. Okay, so let's go ahead and put this function in here. So we have x, okay, to the power of 3/5 and that's times 4 minus x. Okay, so let's take a look at that number there, and then let's take a look at here and here. Okay, so let's take a look at this graph. Okay, now this should support our answer because we can see here that this value at 0, 0 does not have a local maximum or minimum. It's not a local minimum or a maximum point at all. But we can see the point up here at 1.5 or 3 over 2, there is a local maximum. So what this tells us is, and we're going to verify this with our graph, that it supports our answer because there is a horizontal tangent. So what that means is that we have a horizontal tangent here. And what it's saying here is that f prime of the value of c, which is 1.5 or 3 over 2, okay, does equal 0. Whereas over here, we can say that this f prime of 0, okay, does not have a horizontal tangent, so it does not exist.